Okay, today we are going to deal with the shape of distribution 10.8. This is very visual, so we got loads of diagrams done in the book here, and I'm just going to run through them, what they mean with you. Okay, so if you look here, shape number 1. It's big in the beginning, the frequency is higher, so this could be number of people, it's the counting element is on the y-axis. Okay, and gets less as you get higher. This one here, what could you say? The word for this is bimodal. It's got the same two modes, the two highest ones. This one gets, the mode is at the end, the mode is at the start here. This one here is symmetrical. Yeah? If you draw a line down it, it'll fold up onto itself. So, this one. See this thing here that we've got this line, this is a bell curve. A bell curve basically represents most things. Intelligence, weight, height, anything that pretty much can be measured. Any ability, anything like that. Standing, vertical jump or whatever. Okay? So if you see here, it can be the bar chart there. Draw a line down, it would fold up onto itself. We've got the same amount of people who would have excellent IQ as would have terrible IQ, and most people are average. That's the reality of it. Most people are average. These guys, there might be some guys that were here and got to here because they just work harder and create greater myelin in their brain. If you want to look into that, you science lads. Okay, now this is known as a positive skew. Okay, let's just look at this here, bar chart, and they've kind of drawn a line around it. Okay, the tail is to the right. Okay, so positive skew, if there's a positive skew, most of the data is to the left. Okay, so it's positive, it's big in the beginning. That's all it means. You have to know positive or negative. Now, if you think about this one here, I'll draw it in my book. The mode is here. Agreed? Now, this could represent cars or whatever. Or no, this could represent just numbers. Number 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's a histogram, so it'll be 0 to 1. Now, our most common one is going to be there. Yeah? But these guys are kind of outliers, so the mean would probably be here. And here would be the median, the true measure of average. Okay, just as I've got here, mode, median, mean. Why is the mean skewed to the right? Well, it's skewed to the right because there's a few outliers bringing it there. Okay, the median's the best measure, and the mode just follows what's the biggest. Would you use mode here? It's a histogram, it's numerical data. Of course you wouldn't, didn't need to ask you that. This one. In a distribution, the tail is to the right. This negative skew is tail to the left. So the negative skew, the tail goes to the left. So it could be said skew to the left or negative skew. This one here is skew to the right, positive skew. Once again, mode, median, and mean. Median, mode. Okay, as you got here, median, mean, median, mode. So obviously the median is less, or the mean is less than the median, less than the mode. In this one, the mode is less than median, less than mean. Okay, pretty straightforward. Now, they got here examples. Number of children in a family would be positively skewed. The age at which people first learn to ride a bicycle, the age at which people marry. Okay, would be here. Okay, basically the same. If this is 0 to 5, 5 to 10, very few people get married at 70. Let's call a spade a spade. This one would be people that would maybe retirement age or something like that. What do they have here? The ages where people get the first pair of reading glasses. Yeah, the heights of people playing in professional basketball league. Yeah, true. But we still get some small guys playing there. Yeah, and it's slightly changing since I wrote this book. Okay, next page. This is easy enough though. Once again, purposely chose this topic so you won't get too confused. Uniform distribution, everything is the same. Yeah. Bimodal distribution. It's got the same modes. 2 modes. Trimodal would be 3 of the same modes. Okay. Bi is 2. Bicycle, 2. Okay, don't forget that. Common sense never goes astray. Now, distribution. This is A, this is B. This is a histogram, not a bar chart. Don't call it a bar chart. It's not. That's a bar chart. Now, the mean in both of these is the same. But you can see most of the data is between 1 and 2 and 6 and 7 here. And most of the data here is more centralized. So, the standard deviation, the measure from the average, the measure spread from the average would be greater in this one, B, than it would be in A. Okay, I'm going to say it again. The measure spread will be greater in B than it would have been in A. So if the standard deviation here was, let's say, 2, you'd expect it to be greater than 2 here. Okay, you don't need to be able to tell me how much, but you just need to be able to acknowledge that. And go back and we can plug it into your calculator. Now, down at the bottom, this U, what the hell is that U? I'm going to focus in on it. Still a bit blurry. But you can see it there. That U there, that stands, and that U there, that stands for the mean of a population. The X is the mean of a sample. The X with a hat on it. Slight little difference. When I mean X with a hat, that's an X with a hat. Okay, distribution. So when we're looking at C and D, for these, which is a greater standard deviation? Let's run through it. Okay. Now, as you can see, this one, most of it's in around this area. Okay. Agreed? In this one, you've got a huge amount around here. You've got less around here. It's more spread out, slightly more spread out. But this one it's all in the middle between the two. So if you're going to say the mean here might be this, or let's say there's the mean, and this one, there's the mean. All the means around there. There's very little at the end. This has got a huge amount at the end. Yeah, which would indicate furthest point away, if there's a huge amount frequency, then standard deviation is greater as well. Okay, homework is simple. You've got 10 questions. Get through as many of those 10 questions as you can in 40 minutes. Okay, good work, and that's your work for the weekend. Well, except for the weekend, I want you to just go back over and revise some of the work. Okay, so that's 40 minutes for the Friday. Do another 40 minutes or an hour, another one of the days, and you should be fine.